So the module system, and here I am hopefully going to teach you something about the basics of the module system. And the module system is used to access most of the software on Kebnekaise. And we will also try some of the most used commands for the module system, find and list some software modules, and try to load and unload software modules. And I'll also talk about compiler toolchains. So most of the programs on Kebnekaise, you cannot access them directly. You need to load them as a module. And modules are used to set up your environment with paths to executables, libraries, etc. for using a particular set of software packages. It's a tool to help users manage their Unix or Linux shell environment, allowing groups of related environment variable settings to be made or removed dynamically. And the good thing here is it allows you to have multiple versions of a program or package that are easily available by just loading the proper module. Also, modules are installed hierarchically. That means some of the modules you can only access after you have loaded other ones, mainly specific compilers and/or MPI versions. And we will get to that. Some of the useful commands. Lmod, by the way, is the module system. That's what it's called, so that's why. To see which modules exist, you do module spider or short ML spider. And then you get a long list of all the modules available here. And you could, for instance, try and see, let's say, maybe you want to know if there is some Python modules available. So then let's say module spider Python, and then it will list the modules named that is for Python. And you can see here there are many versions available. And you want to know how you load one of those. So you say module spider, and then maybe let's pick this one here, fairly new. Module spider, Python 3.11.5. And then it says some description about it. And then it says you will need to load all modules on any one of the lines, because sometimes there will be more lines, because maybe there's both a GPU version and a non-GPU version and things like this. So first you need to load this here, this module, and then you load this module here. So I'm going to go ahead and load it. And to load something, I either write module load or module add or ml the module. And in this case, I'm copying this here like that. And then I'm also going to copy the module I wanted to load. Both get loaded now. And then I do module list or ml, and then it tells me what I have loaded. And you can see I have loaded the modules I asked for, plus some other things that got loaded together with it. Now, when I have loaded something, there will be more things available, but I can use module avail to see what is available, either with nothing loaded or after loading the things I have currently loaded. And if I want to get rid of the things I have loaded, let's again see what I have. Then I can go ahead and module unload or ml minus the module. And for instance, I'm going to unload Python. Like that. And let's try write ml for module list. And then it shows you most of the stuff went away. We now only have GCC core left here. I will load it again. So now it's back. And another way to unload all the modules at the same time is to use module purge, like that. Now the only thing left are these two, and they contain they are called sticky modules, and they contain some environment variables that are needed for the system and things like that. So leave those alone. And you can also get more information about a module with the command module show. So let's say I want to look at GCC 1320, and then it will tell me what happens, for instance, when I load it, what path will be set and things like this. And now you can see there's nothing loaded, so I'm going to do ml veil. And that means that the only thing I'm shown now are things I can load without loading anything else. And that will mainly be compilers and libraries and things like this. So you can see I can load GCC, for instance, or Java, or Julia. I can also load MATLAB. And other things I can load are those things that are called compiler toolchains. And for instance, FOSS is a compiler toolchain of various versions. And the difference is that a compiler toolchain compared to a regular module is that they contain a compiler and often also libraries, MPI, LAPACK, other things that you would need when you are building something. So you can load a whole lot of things together. So I'm going to try and look at the FOSS and then 2023B, for instance. I loaded that, and now let's see what got loaded. And you can see that loaded GCC, and it loaded MPI, it loaded BLAS and Scalar Pack, and it loaded several other things here. So when you load that, you get loaded most of what you need to build something, compile something. And another thing is when you have loaded a module, then it is easier to see which other modules you can load. For instance, maybe you want to load Python now. And to do that, I will do module load or ML, and I will type Python and a slash, and then I will press tab for autocomplete, and it will then suggest a compatible Python version immediately. So that makes it easy to find versions that are compatible with each other. I was previously talking about the Kebnekaise minus AMD node, and let's go ahead and log into it. And now, since I'm already logged in to Kebnekaise, I can just log in with Kebnekaise minus AMD. I don't need to give the full name or the domain and things, since I'm already inside the domain. And I am now on that login node, and you can see it changed. This is a different node. This is the AMD login node, and this was the regular login node. And there may or may not be some differences between which modules are available. And what you can do is that you check if it's available there, for instance. Let's say what Pythons are available. And when I do that, you can see that it's different. There are much fewer Python versions available on the AMD nodes, and it's mainly the newer ones that are there. That said, we are actually slowly populating the AMD nodes as well, so that we are making sure that most of the software will be there. But if you discover something missing, then you can ask to have it installed, of course. So I will log out of the AMD node again. And now comes some examples here. So now I suggest that you have a terminal window available, either from SSH login or from ThinLink. But make sure you have a terminal window open before you start this. So I can maybe wait 2 minutes, 1 minute, and see that people do that. And you remember that to open it on just 1 moment. To open a terminal window within ThinLink, you went to Applications, System Tools, Mate Terminal. Okay, so let's start. First, try to check which versions exist of the module Python on the regular login node. We just did that, but let us do it again. And I'm going to do clear first so that I get to the top of the screen and we can easier see what I'm doing. So I can say either ML or module, spider, Python. And then it lists the available ones. And you can see that it actually has been updated since I made this example in the fall. So it's different versions. There's now a 3.12.3. And let's see how we can load 3.11.5 on the regular login node. So how would we do that? Well, we will do it with a module spider or ML spider, and then 3.11.5 for Python, like this. And again, it tells us you need to load this and then this. I will do it. It's loaded. And that just shows how you find out here. And then it's suggested to load it, which is what we just did. Let's try to ML. When we see the things that are loaded, there's a lot of stuff because I had forgotten to purge it before I loaded it. So let's simply purge everything. And then I will load. See, there's nothing here. I will just load this again. You can use arrow up to go back to previous commands you have entered. So it's here. I am now unloading Python. And I'm trying with the ml minus Python 3.11.5. And that is gone. I still have the GCC one. And then I will do ml purge. And it's all gone, except the sticky ones. And yes, you can either do the module loads on one at a time, or you could do them all on the same line. but they do have to be loaded in order. You cannot load Python first and then GCC, because GCC is the prerequisite. And if you're loading on the same line, you need to put in the prerequisites first before the other modules. As I said before, the advantage to loading modules one at a time is you can find compatible modules that depend on that version easily by just starting to type the beginning of the module, and then it will suggest the version automatically. So ML GCC 13.2.0. And then we will see what Python they feel is compatible. It's 3.11.5. And then SciPy bundle is a bundle of Python packages that are good for scientific computing. And let's see which one of those are compatible with this Python. So I type ml SciPy bundle / and then I hit tab. And then it suggests me 2023.11. So quite handy in order to see which ones fit together. And then ML to see what you have loaded. So let's take a small exercise. Try and log in to Kebnekaise -AMD with SSH Kebnekaise -AMD if you're already on the regular or thin link login node, and then check what versions of Python are available and see that it's different than the ones on the regular login node. So do ml spider Python on both the regular node or the thin link node and on the Kebnekaise -AMD login node. Let's continue. Let's look at the compiler toolchains. As I mentioned earlier, compiler toolchains are bundles of software that are complete environments for compiling, or also sometimes for using specific pre-built software. And they will all contain a compiler or just CUDA and MPI, BLAS, LAPACK, SCALAPACK, fast Fourier transformations, etc. And what is not listed here is that CUDA is also separately available now as a library. But I just showed earlier that ML AV or module AV will list these. So I will just do a purge and then ML AV, and then we are back to only these compiler toolchains. And then there's an exercise here, but let's do it as a type along. Check which versions of the FOSS toolchain exist and load one of them. Check what is now loaded and then remove all the non-sticky modules. Well, let's first check. We don't have anything loaded. So let's do module spider FOSS. And we're doing this to check which FOSS toolchains exist. And we can see there's a lot of them. We are going to grab FOSS 2023b. So let's do module spider FOSS 2023b. And then we get told this module can be loaded directly. So let's do that. And then we can see that we got a bunch of stuff loaded. Several libraries together with GCC. So let's try do module purge or ML purge. And then let us see what we have. And we only have the so-called sticky modules now. So this worked as expected. So what were the key points? Well, the software on Kebnekaise is mostly accessed through the module system. The modules are arranged in a hierarchical layout. Many modules have prerequisites that needs to be loaded first. And it's worth mentioning here that this differs between centers. Some centers do it the same way as we do, where you need to load prerequisites before you can load the module, whereas others just load bundles of modules so you don't need to load the prerequisites. The modules have some important commands, and some of the more important ones are for loading, module load the module, to unload, module unload the module, or to unload all modules with module purge. And to list the modules, you do module spider, and for a specific module, module spider and the name of the module. And to see which versions are available, you do module spider, the name of the module slash the version that you found from the list you got from module spider and the module name. And you use module list to list the modules you have currently loaded. And then also compiler toolchains are modules containing compiler suites and various libraries. You can find more information about the module system and how to work with it in HPC2N's documentation for the module system. Among other things, there are also descriptions on how you make a list of some modules that you want to load, and like this.